Hello everybody and welcome back. And right now what we want to do is let's implement a function that will take the screenshot of the target's PC. This is something that we saw in the Metasploit framework Meterpreter shell, so let's try to actually implement that as well in our reverse shell. So of course we will not be coding our own screenshot function since that would take a lot of time. What we want to do is basically use a library that already allows us to do that. So let us see which library that is. If you just find or search on the internet, you'll probably find a library called basically the MSS. Now the MSS is a library that allows us to actually take a screenshot with through 2 or 3 lines of the code. Then the screenshot is saved under a certain name, and then we have the screenshot of our target's browser. So we will implement that, so let us just open our reverse shell first, so open it. And what we want to do is first of all go down to the elif statement, so let us scroll down right here. And let's add another elif statement that will allow us to take a function, that will allow us to take a screenshot. So else if the command and the first 10 letters, since that is how many letters screenshot has, equals screenshot, we want to actually try and accept, as always, so our program doesn't crash. We want to run a screenshot function. So we do not have this function yet, but we will code it. For now on, let us just put it here, and let's see what we actually have to do after we have the screenshot. So this is our reverse shell, so we need to read from that screenshot, and we need to send the files of the content of that screenshot to the server. So we will use the similar as before in the file download and upload. We will basically open the screenshot itself, and we will send the encoded content of that picture basically to our server. Now, if you open right here, let me just show you if we can find it. The MSS library saves every screenshot it takes as a monitor -1.png. So MSS library, I mistyped this, but it doesn't matter. We will be able to find it. Let this just load. So let's see, MSS, an ultra-fast cross-platform multiple screenshot module in Python using C types. So let me show you. We will also have to import the C types, so we will do that as well. But right now, let me show you that it saves every screenshot as monitor -1.png. Let me just scroll down. If it says anywhere, we will have to also perform this command since we need to download it in our Wine folder. It doesn't say it anywhere, but trust me, it will save the file or every screenshot it makes as a monitor -1.png. So first of all, we need to think about two things then. If we want to, for example, take multiple screenshots, if it all saves them as a same name, then it basically means that they will overwrite each other. So we need to actually save 2 different screenshots after 2 different names. So let's see how we can do that. But that is something that we need to take care of in our server side of code. So for now on, let us just try to implement the sending of the contents of the screenshot. So with open monitor -1.png. So make sure to specify the same name, since this is the name that the MSS library saves the screenshot as, and we want to specify the read bytes function, so we read from the image, and let's save it as CS, for example, as screenshot. Then 2 dots at the end. Oops, where are 2 dots? There they are. And we want to reliable send this function or this screenshot. Reliable send base64, since this is a picture, we want to encode it so it doesn't crash. Base64 encode cs.read. and we specify the open and close 3 brackets. So this is basically what we want to try to do. And after this, we also want to remove the screenshot so it doesn't stay on the target system. Since when we use the screenshot function, it will save the screenshot on the target PC. Then it will read from it and send it back to us. So we do not want to leave that screenshot there. We want to actually delete it right after it sends it so the target doesn't see it. So os.remove is the function that we will use from our OS library, and then we remove monitor -1.png. Now make sure to specify the correct name, otherwise this will fail. And then in the accept, we want to send a normal reliable send, exclamation mark for the error. First of all, let me just find the double quotes, there they are. Failed to take screenshot. And then we close this. So we send an error in a message that will say failed to take a screenshot. And right now what we want to do is basically just find or basically code the screenshot function with the MSS library. So first of all, let us go up and import the MSS library as well as C-types. So import C-types. Maybe we'll need it. It said that it is based on C-types, and also type here from MSS import MSS. This is how we will use it. So once you specify it, let's add the function itself. So let's add it right here. Def screenshot, since that is what we specified in the coding of else if statement. So, and all we have to do right here is, if you knew the syntax, it would be very simple. So right now with MSS as a function, as screenshot, we just want to type here screenshot.shot. This will perform the screenshot function. It will save the screenshot as monitor -1.png, and then we will read from it in our else if statement. We will open the file for reading, and we will send the file with the reliable send and base64 encode. Then we will remove the screenshot so it doesn't stay on target PC. In case that doesn't work, we will send to our server failed to take screenshot. So let us save this and close this. Since we were done with the reverse shell side, now we want to do is open our server and actually code the part of the server code for the screenshot. So what we need to do, we do not need any function for this. All we have to do is handle the message back properly. So let's add an else if statement. Else if command is first telnetters are screenshot equals to screenshot. We want to try to receive the screenshot. So with open, and right now we need to specify the thing that I told you before. So if we open the file, we need to make something that will open every screenshot with different name. So what we will do is we will add a variable called count, for example. So let us do it right here. Global count. We make a variable that will count our screenshots. So we go down here, so add it just below the shell function, and then go down here with open, and then we need to specify the file name to be different. So we will use the %d for a number. We will close this. Let me just open the apostrophe at the end as well. So screenshot %d, and then we want to instead of %d use count every time. So count and then comma write bytes. So we want to write the screenshot. We want to call it, for example, as screen. We call that is the file name, and what we want to do right now is add a variable, for example, called image. So image equals reliable dot or underscore receive. This is us receiving the image itself, and right now what we need to do is decode the image with the base64. So let us do image decoded equals base64.b64 decode, and then we paste the image to be decoded. Now, we need to specify, since we are receiving either an image, if it works well enough, or either a string that says fail to take image. So this image variable right here will either be a content of a screenshot, or it will be a simple string that says fail to take screenshot. So once we decode it, we need to check if it contains if image underscore decoded and first 4 characters equal to this. So this is something that we specified in the reverse shell function when it fails to take screenshot. So these are the first 4 characters, and after that goes failed to take screenshot, but we'll only specify first 4. If the first 4 characters are equal to this, we want to print the image dot underscore decoded. So we actually know that it failed to take the screenshot. Else, we want to write the screenshot to the file. So screen dot write image decoded. So simply explained, this means that once we receive either an image or a string, we check if it is we first decode it, then we check if it is a string with these 4, if it is an error message. If it is not, it will write the contents of the image to the file screen. Now also what we need to do is, after this works, we need to increase count by 1. So for example, if count equals, I don't know, 3 or 4, and we also need to specify, we need to specify count to be a number, so we set global count, and let's specify it then up here, since we put it to be global. Not really sure if it has to, it probably doesn't have to be global, but since we said that it is global, we will set count to be 1 for the first time, and we will use it right here. So global count is 1, so the first screenshot will be saved with the name screenshot1. The second screenshot, since this will be increased by 1, will be named under the screenshot 2, and so on, for as many screenshots as we take. So let us see how this works. Control O to save, Control X to exit, and we need to compile the program. So we use the same command. Let me just find it once again. Here it is. But before we use this command, what we have to do is actually install the MSS library and ctypes library, but I believe it already has ctypes, into our Wine folder. So we use wine/root.wine, drive C, Python 27 and python.exe, then -m for the pip. We use pip to install MSS. I believe we can use it with this right here. So let's see if this works. It should work. So we are installing the MSS library for our Wine Python, collecting MSS, and hopefully it will download it successfully. So we will see. And we can see it all finished successfully. So installed collected packages, MSS, successfully installed MSS. So let us see for the ctypes as well. It probably does have them, but just in case, so we don't actually run into an error, let us collect that as well. If it has them, I believe it will say something like requirement already satisfied or something like that. If it doesn't have them, it will download it, and we will be able to use ctypes as well. So no matching distribution, so we already have that. Okay, so let us compile this right now with the same command. So one file, no console, press enter right here. In meanwhile, we delete this file, which is previous reverse shell. Are you sure? Yes, I'm sure. Then we go and plug in our USB drive. So simple as before. And as soon as this finishes compiling, we can paste it to the USB drive. So dist move reverse shell to the media root Kali Live. We move it, we go one directory back, and we run our server. Unexpected unindent. So let us see, we have a code error in our server at else, so let us see where it is. Not really sure. If else right here. So what is the error? I'm not really sure if it has anything to do with this, so let us see. If image with open try accept. Oh yes, so we didn't even code the accept rule. So what happens when it doesn't work? So accept, we want to print an error, or actually we do not need a try and accept challenge right here. We have it in our reverse shell, so we can just delete this. We can just leave it without the try and accept. So let us see once again, server, listening for incoming connection. So basically at the screenshot part, just delete the try that we added since we do not need it. What we want to do right now, we want to go to the, did I unplug my USB drive? So first of all, unplug the USB drive. And right now, what I want to do is basically run the reverse shell.exe, again from the USB drive. It doesn't even matter, you can paste it on your desktop and it will work the same. So let us see how this will work right now. Let us lower our screen so that the screenshot actually takes the part of the screen of Windows 10 as well, so it doesn't take only the screen of the Kali Linux machine. And if I just type here screenshot, it will take a few seconds in order to take the screenshot and also send it back to us, I believe. And soon enough we should receive screenshot successfully taken or something like that. So let's see. It's taking a rather long time. We didn't receive anything, so it means I believe that the screenshot worked well enough. As we can see on the desktop, we do not have any monitor -1.png. So we can also take the screenshot with Kali Linux machine in the lower right corner, so we can see that it saved properly with screenshot 1 and screenshot 2, that it doesn't overwrite the screenshot. So let us see. As we can see, it does take a few seconds to perform this, but it should work once we check the folder of our Kali Linux machine, which is the same folder as our server. So let us open this up. We do not need this anymore. We can quit the shell, and if I just type here ls, we have screenshot 1 and screenshot 2. Now let's see if they are actually the pictures that we took from our monitor of Windows 10. So let's open the folder. We go to the root. We go to the Python programs. So let us find Python programs, reverse, and as we can see, screenshot 1 and screenshot 2 are good screenshots of our target desktop. So right now, as we can see, we can successfully take screenshots of the target's machine. So this is another useful thing we coded, and we will continue in the next video. Hope you enjoyed this one, and I hope I see you in the next one. Bye.